Good day, everybody, and yet again we are back. And yeah, so today I just want to treat the electrolytic cell. Okay, so that's we've already done just some revision on the galvanic cell, right? By the way, if you haven't subscribed, please make sure that you're part of the family, and tell more people about this channel. Tell them you're learning great things, okay? By the way, for those of you who are looking for assistance in mathematics or physical science, all right, please just make sure to hit us up. The email address is info@mlungisinkosi.co.za. All right, let us get into it. Okay, so they say the diagram below shows two electrochemical cells in which carbon electrodes are used. In cell A, we've got concentrated copper chloride solution, okay, and in the other cell B, we've got liquid aluminium oxide, which is used. And by the way, ladies and gents, I've got videos that I've made earlier on copper chloride, but I've also got another video on just in fact on electrolytic cells, and I've got a separate video on the processing of aluminium, the purification of aluminium from aluminium oxide. Okay, so please just go and check those out. They will kind of help you from the theory behind the operation of the cell. All right, now let's get to the first question. They say, what type of electrochemical cell, electrolytic or galvanic, is shown above? Give a reason for the answer. Okay, so we know it's going to be an electrolytic cell. All right, but why is that? Okay, because remember, here we are converting electrical energy. How do I know that? Because we have got a DC source there. We've got a battery. Okay, we're converting electrical energy into chemical energy. Okay, right. You can also say because we've got a battery there. All right. Remember, in a galvanic cell, it's the other way around, right? We are converting chemical energy into electrical energy. So you'd see there'd be a voltmeter instead, because you are measuring the amount of potential that's given. All right. So they in the next question, they say write down the half reaction that takes place at the anode of the cell A. You know what I want to do, ladies and gents? Let me approach it this way. Let me just show you quickly what's happening in either one of the cells, right? In fact, in both of the cells. So if you think about, let's take cell A for argument's sake. You've got a positive side and you've got a negative side. Okay, and what's happening there is that you've got copper chloride. Okay, so you've got copper chloride as your electrolyte over there. And so what would tend to happen is the process of electrolysis. Okay, remember, copper chloride is actually two things. So copper chloride is actually copper 2 plus ions, but it is also chloride ions, right? So now what happens? On the positive side of my cell, okay, what happens? On the positive side, I know I'm going to actually have those chloride ions being attracted towards that guy, right? So as a result, okay, you can take your standard reduction table. So what happens? Your chloride ions will actually now change into chlorine, right? I just want to open it up for you so that you can see it there. Okay, so let's find chlorine. So you start with your chloride, and they are actually they're going to undergo oxidation. And by the way, remember, in the electrolytic cell, the anode is the one that's positive, whereas in the galvanic cell, the anode is the negative cell, right? So what's going to happen there? I'm going to have 2Cl minus, okay, becoming, so if I were to call this P, and if I were to call that Q, So at electrode P, this is the reaction that's taking place. 2Cl minus would become Cl2 by actually losing 2 electrons, right? So it would undergo oxidation, whereas in Q, all right, so we're going to be attracting those copper 2 plus ions, right? They're going to be seeing those electrons there. So in actual fact, you're going to have copper 2 plus undergoing reduction, okay? So by receiving electrons and therefore becoming copper. So there are three things that you're going to observe in this cell, okay? First of all, you are going to have, usually copper chloride is blue in color, right? So the blue color would sort of fade, okay? So it would become faint. And then number two, you would have the bubbles forming. So you'd see that there'd be bubbles forming at electrode P, all right? And then thirdly, what you would have is that obviously because you're forming copper at that cathode there, you would actually see the electrode turning brown in color, the color of copper, that bronzish brown color, okay? Right. So they say to us we should write down the half reaction that takes place at the anode of cell A. Okay. Remember, we said the anode is the positive one. Okay. Remember, the anode is where oxidation takes place, right? Which is the loss of electrons. So in this case, it would be this cell over here. Okay. It would be this half cell over here. So I'd say 9.2.1. Obviously, we're going to just simply write there. This is going to be 2Cl minus would become Cl2, okay, by losing 2 electrons. So that's the reaction that takes place in the anode. Right, and then for the half reaction that takes place at the cathode of cell B. Now remember, in cell B, okay, just once again, all right, I just don't want to give you on just the answers. So let's see what happens in cell B. In cell B, and obviously you're going to still go and watch that video there because there are some parts that I'm just not going to talk about, the effect of cryolite and all of that, right, and alumina and all the other stuff. Right, so now I've got this guy being positive, okay, and that one becoming negative. Now remember, how does aluminium oxide look like? So it's Al2O3, okay. Remember, in this case, what do you have? You've got aluminium, which is Al3 plus, but you also have oxygen, which is O2 minus, right? So and I know I didn't actually represent it as I should. Okay, so this would be 2Al3 plus, and this would be 3O2 minus. Okay, right. So in this case, sorry for writing it in such a horrible manner. Okay, so what do you have here? So in this case, you know that the positive our cations, the positive ions, would actually go onto that side to form aluminium, pure aluminium in this case, whereas oxygen would now be formed at that there. Let me see if I can find the half reactions thereof in the other cell. Nah, in fact, you know what? Let's just continue. So what you'd have here is that aluminium obviously would, be attracted towards the negative side. So you know that you'll have Al3 plus ions, okay, receiving 3 electrons. And what would they become? It would become aluminium, okay. And then you also would have oxygen, okay. It's actually N ions, so they would go to that side. So O2 minus, okay, would actually become O2 by actually giving away electrons, okay, by giving away those electrons there. All right, in fact, if you look at both cells, you would actually get a net cell reaction. So I just want to show you the overall cell reaction there. So what you would get here, of course, the electrons would sort of cancel each other there. So in fact, the net cell reaction would be, I'm just going to write it there. So you'll have copper chloride, which would give you Cl2, which is the gas, okay, and it would give you plus copper, which is solid. So that's the net cell reaction. That's the overall cell reaction, okay. Whereas when we look at this one, if I were to try and make the net cell reaction, okay, I'm just going to take this up a little bit. Okay, so what I would have to do first would be to just make sure, and ladies and gents, I know that I'm not really answering questions there, but I just want to show you how to do that. So what I would need to do is just make sure that the number of electrons are balanced there. So I would multiply this one by 2. So 2 there, I would have 6 there, I would have 2 there, and this one I'd multiply by 3 so that the number of electrons are equal. So this would be 6. So once they are equal, so my net cell reaction would be 2Al3 plus 3 plus 3O2 minus. Okay, you can actually just write it down as 2AlO3, which will give me, it would be 2Al plus 3 oxygens. Okay, you can actually write this down as 2Al or Al aluminium oxide, Al2O3, right, which will give us 2Al plus 3 oxygens. Okay, right, in fact should have been 4Al there. Okay, so that should give us 4Al rather. Okay, right, so this would be the net cell reaction, right? In this case, the last part of it, okay, what did we have? Oh yeah, I see. In fact, I just made just a slight error there. Yeah, yeah, but Oxala, it's going to be 4Al and 3O2, which is oxygen there. Yeah, let's just move on. All right, so in this case, they said we needed to write down the half reaction that takes place at B, okay, and at the cathode of cell B. Remember, cathode, this is where reduction takes place. So which one is reduction? It's the gain of electrons. So in fact, that would be the reaction that takes place there. Okay, so it means, let's just write it out. Okay, I'm just going to move over to that side. So remember, it means that what happens there, this is going to be Al3 plus. Okay, remember we are gaining electrons, so I'm just writing it in the original form, right? Plus 3 electrons, that would give us Al, aluminium. Okay, right, so that means that is what would be taking place at the cathode of cell B. Now they say to you, name or formula of the product formed at the cathode of cell B. So what was formed there? So they said name or formula, so you can either write there Al or you can just write it out in full, aluminium. Okay, right, and then so that would be 9.2.2 and that would be 9.2.3. All right, now let's get to the conclusion. All right, they say give a reason why the mass of electrode Y would decrease after a while. Now, electrode Y, remember that in the electrolytic cell, just to remove that there, this electrode, so this would be electrode Y, right? So what was happening at electrode Y? This is where we were attracting those oxygen, N ions, right? So what happens? Sorry, not oxygen, those oxide rather ions. So in this case, what happens? We are forming oxygen at that electrode. Okay. Now, what really happens at that cell? Of course, perhaps they didn't ask us to do this, but I want to show you. What happens is that they actually use carbon rods, right? So if you think about it, and that's why it's really not ideal to use this kind of a cell for the environment. Okay, so the carbon rod there now begins to react with oxygen, and carbon dioxide is formed, right? So that's why you would actually have this guy decrease, because over time, as we form carbon dioxide, it means the mass of carbon, the carbon rod would actually decrease. Okay, you didn't need to show that with a reaction unless they asked you to, but in this case, that is how the cookie crumbles. Okay, right. So I really hope that you understood, you enjoyed the cell. So I went a little bit further. Rather than just to answer the question, I just helped you understand the theory behind. But I still think it would benefit you to go and watch the other videos so that it would expand your knowledge in this section. Otherwise, ladies and gents, thank you so much for watching yet again. And I guess I'll be seeing you again as you keep preparing. Please keep working hard. Okay, right. Sharp, sharp.